বিসমিল্লাহির রহমানির রহিম। মেকানিক্স অফ সলিডস তৃতীয় ক্লাসে তোমাদেরকে স্বাগতম। আজকের ক্লাসে আমরা সিম্পল স্ট্রেস অ্যান্ড স্ট্রেন রিলেটেড আমরা কতগুলো 8 থেকে 10টি আমরা এক্সাম্পল প্রবলেম করব এবং এই এক্সাম্পল প্রবলেমগুলোর উপর ভিত্তি করে তোমাদের কিছু অ্যাসাইনমেন্ট দেওয়া হবে। ওই অ্যাসাইনমেন্টগুলো তোমাদের করতে হবে। সো আমি আজকে তোমাদের ফলো করব স্ট্রেংথ অফ ম্যাটেরিয়ালস বাই পাইটেল অ্যান্ড সিঙ্গারের বুক। সো এই বইয়ের আমরা কিছু অনুসরণী বা এক্সারসাইজ থেকে কিছু অঙ্ক করব। সো আমরা শুরু করতে পারি। শুরুতে আমরা সিঙ্গারের বইয়ের 106 নাম্বার প্রবলেমটা করব। সো প্রবলেমটা যদি আমরা দেখি, the homogeneous bar shown in figure 106 is supported by a smooth pin at C and a cable that runs from A to B around the smooth peg at D. Find the stress in the cable if its diameter is 0.6 inch and the bar weighs 6000 pound. So I am again describing the question. This is a bar ABC which is supported by a cable that runs from A to B through point D and a hinge support at C. And the cross section and the diameter of the cable is 0.6 inch and the weight of this ABC bar is 6000 pound. We are to find the stress in the cable. So we can start our solution. To solve this problem, we initially draw a free body diagram. The free body diagram of this bar ABC will be like this. And at A point, at B point, the cable is connected. And if we draw the free body diagram of bar ABC, then D point will not be required, and this is C point. There is a hinge support. Think as the cable runs from A to B over the point D and the peg at point D is smooth, so there will be no friction force loss, and as it is a single cable, so force in each point of this cable will be same. সো অর্থাৎ এটা যেহেতু একটা একই রশি এবং একই রশিতে আমাদের সকল এবং এখানে একটা ফ্রিকশনলেস মেম্বার উপর পাস করেছে, সো সকল জায়গায় একই টান। আমরা চিন্তা করতে পারি একটা রশিকে যদি আমরা কোনো একটা স্মুথ প্যাগের উপর বা যে কোনো জায়গা দিয়ে টানাটানি দুই পাশ, মনে করি আমরা একটা সাজদের একটা বাঁশের, মনে করে একটা ব্যাম্বু পিলার বা একটা পিলার বা ব্যাম্বু এর এখন আমরা দুই বন্ধু যদি রশিটাকে এইভাবে টানাটানি করি, সো রশিতে একই ফোর্স, অর্থাৎ রশিতে এই প্রান্তে যে পরিমাণ ফোর্স থাকবে এই প্রান্তে একই পরিমাণ ফোর্স থাকবে, এটাই। সো এইখানেও এই ক্ষেত্রেও আমাদের যেহেতু একই রশি, সো এ পয়েন্টে রশিতে যে পরিমাণ টেনশন বা টান থাকবে এবং বি পয়েন্টে একই পরিমাণ টেনশন থাকবে। আর একটা জিনিস আমরা খেয়াল করতে পারি, কেবল ইজ এ টেনশন মেম্বার, সো উই ক্যান কনফার্ম দ্যাট দেয়ার উইল বি টেনশন ইন দ্য কেবল। And so another, we have also the dimensions given. This is 5 meter, and it's also 5 meter, and the weight of this bar is 6,000 pound. Though it is not stated, we know that weight of its body acts at the CG of this section, as the bar is 10 meter and B point is at mid is the middle point, so weight 6,000 pound will also act at point B. Another thing, we need the angle at A at which the cable acts, and if we are to find this angle, and from this figure we know that at tan theta equal লম্ব বাই ভূমি, এই লম্ব বাই ভূমি যদি আমরা করি, সো we can write tan theta equal BD by AB. So tan theta equal 3/5, then theta equal 30.96 degree. So this value is known to us is 30.96 degree. And at first, as we are to find the stress in the cable, so we need the force T, and if we get the value of T, then we can easily find the stress by dividing this force by cross-sectional area of the cable. So as the point C is also a hinge point, and it is also stated in the point, supported by a smooth pin at C. It is a pin support. Pin support is always is hinge support. So as C is a pin support, so moment about C is 0. So if we take clockwise as positive, rotation clockwise positive, moment about C equals 0. So the force at A, that is this force acts at an angle 30.96 degree with the horizontal, and it have two component. It is one is horizontal component and one is vertical component. The horizontal component is T cos 30.96 and vertical component is T sin 30.96. One interesting thing here is the horizontal component at A passes through the point C, so there will be no movement created by the horizontal component. So we can easily write the only vertical component will create moment, and this will be the force multiplied by the distance. So perpendicular force multiplied by the perpendicular distance. So we can write, and clockwise is this, as this is clockwise, so it is clockwise T sin 30.96 force into perpendicular distance, that is 10 meter, again plus T is also is clockwise direction, so T plus T into perpendicular distance is 5 meter, and this 6,000 pound acts in the opposite direction minus 6,000 pound, as this force will create anti-clockwise moment about C. All moments are calculated with respect to C. So this is really, and it's also at a distance of 5 meter. So if we calculate this, the T becomes, so the T becomes 2,957.41 pound. If you go through the calculation again, this 10 sin 30.96 plus 5 equal to 10.144 T meter, and if we send it in the right side, then the direction will be plus. So it is 30,000 pound meter, and the result is T equal 22,000, is almost 3,000 pound. So we have to find the stress at the cable, on the cable. So we know that force equal stress into area, that is T equal sigma into A. So we know that T equal 2,957.41 pound equal, and we have to find the sigma, and cross sectional area is 1 by 4 pi d square, and the cross section area of the cable is 0.6 inches square. So ultimately we can get sigma equal by using calculator. We find the stress is 10,459.68 pound per inch square, as the fourth unit of the force is pound and the unit of the cross section area is inch square, that is pound per inch square, or PSI. You can write any one of these. Next we'll move to another problem. Now it's another problem which is a principle of superposition. That is, in a member there will be composite sections, that is it may be made of two different materials or the different dimensions of a similar materials, and we will have to calculate the stress on an elongation of in such materials. This problem the problem which is 107 now of 107 of single book is on the stress of a composite materials. If we go to the question, so we find this: a rod is composed of an aluminum to be a rod. আমরা যদি বলতে চাই রড কাকে বলে, রড হচ্ছে যে কোনো ম্যাটেরিয়ালসের একটা সরু অংশকে, এটা দ্যাট নট নেসেসারি যে স্টিল হতে হবে। রড মানেই হচ্ছে যে কোনো ম্যাটেরিয়ালসের একটা সরু দণ্ড। এ রড ইজ কম্পোজড অফ অ্যান অ্যালুমিনিয়াম সেকশন রিজিডলি অ্যাটাচ বিটুইন স্টিল অ্যান্ড ব্রোঞ্জ। এই আমরা যে রডটা আন্ডার কনসিডারেশন সেটা হচ্ছে একটা অ্যালুমিনিয়াম সেকশন রিজিডলি অ্যাটাচ, দুইটা আর অ্যাটাচ বিটুইন হচ্ছে কি দুইটার মাঝে স্টিল অ্যান্ড ব্রোঞ্জের মাধ্যমে, অর্থাৎ এটা যে রডটা আন্ডার কনসিডারেশন এটাতে আমাদের আর থাকবে অ্যালুমিনিয়াম, স্টিল অ্যান্ড ব্রোঞ্জ, অ্যান্ড মাঝখানে থাকবে অ্যালুমিনিয়াম এ শোন ইন ফিগার। সো আমরা ফিগারটা দেখবো। এক্সিয়াল লোডস আর, সো আমরা দেখে নিই ফিগারটা। এই ফিগারে দেখো অ্যালুমিনিয়াম সেকশনটা আমাদের ব্রোঞ্জ এবং স্টিলের মাঝখানে আছে, এবং পরবর্তীতে axial loads are applied at the positions indicated. Axial loads are applied at the position indicated. So axial load আমাদের position indicated একদম ফ্রি মুক্ত প্রান্তে বা ফ্রি ইন্ডে আমাদের স্টিলে 4p টেনশন দেওয়া আছে এবং ব্রোঞ্জে ইন্টারনালি কম্প্রেশন দেওয়া আছে। If P equal to P is 3000 pound, so the value of P is also given. The cross-sectional area of the rod is 0.5 inches square. It is a uniform section that at all the sections the cross-sectional area is 0.5 inches. Determine the stress in each section. আমাদের প্রতিটা সেকশনে স্ট্রেসের মান ভ্যালু করতে হবে, অর্থাৎ আমরা প্রতিটা সেকশনে আমাদের তাহলে কি ফোর্স বের করতে হবে, এবং তারপর আমরা ক্রস সেকশনাল এরিয়া দিয়ে যদি ডিভাইড করি তাহলে আমরা স্ট্রেস পাবো। সো আমরা যদি বোঝার সুবিধার্থে চিত্রটা বা ফিগারটা আমরা এগেইন ড্র করি, তাহলে দেখো আমাদের এই ফিগারটা হবে এরকম। ফ্রেন্ড initially bronze, then aluminum, then steel. It is fixed support and it is freed, and axial loads are acting at this point. It is 4p, and as per the question P is 3000 p, so 3000 pounds, so 4p is 12,000 pound, and there is another force P that is 3000 pound, and length of each segment is given, that is 2 feet, though we will not require length for this problem. So we are writing, so আমরা যখন এই কাজটা করব, এই ধরনের প্রবলেম সলভ করব, তখন আমাদের মেথড অফ সুপারপজিশন সবচেয়ে বেটার ওয়ে হচ্ছে আমাদের জন্য এই এলিমেন্টটাকে আবার ড্র করা এবং সেগমেন্ট ওয়াইজ। আমরা যদি প্রথমে সেগমেন্ট ড্র করি, স্টিল সেগমেন্ট, দেন আমাদের ড্র করতে হবে অ্যালুমিনিয়াম সেকশন, তারপরে আমাদের ব্রোঞ্জ সেকশন, এবং বোঝার সুবিধাতে আমরা দরকার হলে সাপোর্ট সেকশন আঁকতে পারি। খেয়াল করে দেখো, আমরা এখানে সুপারপজিশন হচ্ছে আমাদের পুরো মেম্বারটা একই সাথে কাজ করে, সেটা হচ্ছে মেথড অফ সুপারপজিশন। সো আলটিমেটলি পুরো মেম্বারটা কি আমাদের জায়গায় স্থির আছে এবং প্রতিটি অংশ, প্রতিটি সেগমেন্টও আলাদাভাবে স্থির আছে। এই দুইটাই কনসেপ্ট ইউজ করে সো আমরা এটা সলিউশন করব। সো দিস ফোর্স ইজ গিভেন অ্যাজ 12,000 pound. As there is no internal additional force in steel, so it will be in tension. It is 12,000 pound. So steel will be in tension of 12,000 pound, and to get this we are adding this additional force 12,000 pound to stabilize the steel. So we, to minimize it or to nullify it, as it is external force, we have to give same magnitude and opposite direction force 12,000 pound in aluminium. And as there is no additional force in the aluminium, so it will be we have to give again 12,000 pound to stabilize it. And in the bronze, this will be in opposite direction. It's 12,000 pound, it's in tension direction, and there is, in the bronze there is additional one force, that is 3,000 pound is given. So in left side of the bronze there is two forces, one is 12,000 pound tension and another is 3,000 pound compression. So ultimate result, the summation will be 3,000 pound, 12,000 pound tension, 3,000 compression, so 9,000 pound tension. So it will be 9,000 pound. So now we know the forces in each segment, so easily we can calculate the stress, as the cross section area is 0.5 inches square, that is we calculate. So we are going quickly little bit, as we have the opportunity to pause the video when you are when things are not clear and revise it. So I am going to some little bit faster. For steel, F equals sigma A, that is sigma equal F by A, that is 12,000 pound by 0.5 inches square, that is 24,000 pound per inch square, so 24 KSI. Similarly for aluminium, sigma equal F by A, so and F equal, we know F equal is for the aluminium is also 12,000 pound, and the cross section area is also same 0.5 inches square, that is equal to 24 KSI. And for now, for bronze, the force is 9,000 pound tension, so sigma equal 9,000 pound by 0.5 inches square, that is 18,000 psi equal 18 KSI. So stress in every section are now known. So we got stress in steel is 24 KSI, stress in aluminium is 24 KSI, and stress in bronze is 18 KSI. এখন আমি চেষ্টা করব তোমাদের রেফারেন্স বুক সিঙ্গারের বুকে 211 প্রবলেমটা সলভ করার জন্য। দিস প্রবলেম নাম্বার 211 and the problem is shown in this display, and as you are you can understand the method of superposition, so I'll go a little bit faster. And from this, let us see the figure, or I try to understand the condition of this figure. In this figure there is a steel bar, bronze bar and aluminum bar connected. Three bars or three rods are connected, and the cross-sectional area of steel, bronze and aluminum are different, and they are 480, 650 and 320 millimeters square respectively. And the length of the each segment or section is different, and is also given 1 meter, 2 meter and 1.5 meter. And there is also shown some forces that's at the starting point of steel and bronze and aluminum sections, and these three different materials. So we can go into the question. The question is, a bronze bar is fastened between a steel bar and an aluminum bar as shown in figure. Okay, a bronze bar is fastened between steel and aluminum bar as shown this figure. Axial loads are applied at the position located. So, and 2, 3, 4 axial forces are shown. Find the largest value of P that will not exceed an overall deformation of 3 millimeter. So we have to find largest value of P, the highest value P that is possible. The condition is maximum deformation of the whole system or overall system will be under 3 millimeter, or there is another condition or another thing. There is or the following stairways: 140 megapascal in steel, 120 megapascal in bronze and 80 megapascal in aluminum. সো আমাদের নেক্সট যে শর্তটা সেটা হচ্ছে, এই স্টিলে আমাদের 140 মেগাপ্যাসকেল ক্রস করতে পারবে না, ব্রোঞ্জে 120 মেগাপ্যাসকেল ক্রস করতে পারবে না, এবং অ্যালুমিনিয়ামে 80 মেগাপ্যাসকেল ফোর্স ক্রস করতে পারবে না। আর অ্যাজাম্পশন বলতে দেওয়া আছে আমাদের, the assume that assembly is suitably braced to prevent buckling, so there will be no buckling, so deformation or flexural stress is absent in this question. And the value of modulus of elasticity for different materials is also given, and it's for steel is 200 gigapascal, and for aluminum is 70 gigapascal, and for bronze is 83 gigapascal. So let us try to draw the figure and make it clear to us. So I am drawing the same figure. So this force, and as the properties is all shown in the figure, so I am not drawing again. So I am drawing only the forces which we will use for solution or method of superpositions. So if we draw Freeburg diagram separately, that is for steel, and for the bronze, steel, bronze and aluminum, good combination, steel, bronze and aluminum. So there this force is P, is outward, so it is tension. So as there is no force in the steel section, so this force will be P, and these will be in equilibrium. To minimize this force, we have to put another force P in the bronze, and as another 3P force in compression is given at bronze. So ultimate summation is 2P tension in bronze. So to minimize it, and there will be a 2P force It's a compression from both sides, and to neutralize it, and there will be additional 2p force, but another force is given is 4p tension to aluminum, so there will be another 4p tension. So summation at the aluminum will be 4p tension minus 2p compression, that is 2p tension. So is also 2p tension and is also given. So now we know the forces in each segment in terms of P, and we also know the allowable stress in each segment. So consider, based on allowable stress, we can find the value of maximum value of P. So we are to solve this problem. Is it firstly? So based on allowable stress, ball stress, we are calculating the P value. So for first portion, therefore steel, we know F equal, we know force equal to stress into area, and for steel the force is, therefore steel the force is P. So P equal, and sigma is given for steel is 140 megapascal. We all know, we can remember the 140 megapascal means Newton per millimeter square, and cross sectional area of steel is also given as 480 millimeter square. So Newton per megapascal is Newton per millimeter square into 480 millimeter square. So the resultant will be is Newton, and it's 67,200 Newton. Similarly for bronze, in the bronze there is 2p force is 2p, so it is 2p equal, and allowable stress for bronze is 120 megapascal. So 120 megapascal, that is Newton per millimeter square, into cross section area of the bronze, it is also given as 650 millimeter square. So the force will be in Newton, and it's 70,000 Newton. And now we are to find the stress for aluminum section. So for aluminum, also for the aluminum, the force is 2p, is the tension. So, and if we can remember that there is no connection between tension and compression in calculating stress. So 2p equal, allowable stress for aluminum is 80 megapascal. So 80 megapascal into cross sectional area of the aluminum is 320 millimeter square. It's 320 millimeter square, and this force will be 25,600 Newton. Remember, this value is for 2p. So P equal 12,800 Newton. Similarly for the bronze, is the value is 2 for 2p, so we can write P equal 39,000 Newton. So based on allowable stress, the maximum value of P is 12,800 newtons. This is because if the P value exceeds 12,800 newton, then the stress in the aluminum will be more than 80 megapascal, which we cannot exceed. Now we are to find the P value, maximum value of P in terms of deformation, that is total elongation or deformation. So deformation, that's so the member can be elongated or compressed maximum 3 millimeter, and we will find the corresponding p value. So if we remember, we know del L equal PL by AE. Del L equal PL by AE. This we will have with the help of this equation we will find. And for making things easy, we are to draw the figures from the previous page again. So ultimate summation was, in steel it was P tension, in bronze it was 2P compression, and in the aluminum it was 2P tension. So we know that for tension the member gets elongated, and for compression the member shortened. So the steel and aluminum which are in tension will be elongated, and the bronze will be in shortened. So ultimately, if we calculate the summation of the resultant, so we have to add elongation of steel and aluminum and subtract the elongation of bronze. So as the overall deformation is limited to 3 millimeter square, 3 millimeter, sorry. So ultimately we write in advance del to del equal the total elongation is 3 mm. Please remember, we are calculating every problem in Newton millimeter. So it is 3 millimeter, and its elongation is delta steel minus delta bronze, is it will be shortened, plus delta aluminum is 3. If we write everything in Newton millimeter, so and delta steel equal to PL by AE, everything will be for steel, minus PL by AE for bronze, plus PL by AE for aluminum, equal 3, is equal 3. So as we know the P value and length is also given. Steel is 1 meter, bronze is 2 meter, and aluminum is 1.5 meter. So if we put these values in this equation, and E value for steel, bronze and aluminum also given, and cross sectional area is also different. So if you put this value for steel, it is P is equal P, length is 1 meter, that is 1000 millimeter, is everything will be in Newton millimeter, cross section area is 480, so no need to convert, it is in millimeter square 480, and E value for steel is 200 GPa. So 200 GPa is 200 into 10 to the power 3 megapascal, that is Newton per millimeter square. Nice. Then P value for bronze is 2P, length is 2 meter, that is 2000 millimeter, and cross sectional area is 650 millimeter square into modulus of elasticity for